Coterminal angles. When we were looking at angles in standard position, we talked about going a complete loop from 0 to 360 degrees, either clockwise or counterclockwise. But there's no reason we had to stop there. It may seem a little bit silly to keep going around and around and around, but if I take an angle, let's just take a nice simple 45-degree angle, and notice that instead of just going directly there, I might make a full loop before getting there, which would be 360 plus 45, which is 405 degrees. Or maybe instead of just one loop, I made two loops before getting there, which would be 405 degrees plus another 360 degrees, which is 765 degrees. For our purposes, for analyzing static positions, these angles are all equivalent. There are some applications where talking about the exact value instead of the simpler value is more important. If what matters is the final position of the thing that is rotating around, then it's all the same. But if instead you imagine driving a screw into a wall or tightening a bolt, making two complete loops and then twisting a little bit further will tighten the bolt quite a bit more than making just one complete loop before tightening it a little bit further. But again, for our purposes, it all works the same. So as a general rule, we're going to be doing exactly the opposite of what I was just doing and trying to find a way to write our angle somewhere between 0 and 360 degrees. Or, if we're in radians, somewhere between 0 and 2 pi. So, if I have an angle like 1295 degrees, I can subtract off complete loops around the circle as many times as I would like. So let's subtract 360 degrees. That takes me to 935. Let's subtract off another 360 degrees. That takes me to 575. And let's subtract off one more 360-degree rotation. When I do that, it takes me to 215 degrees. So this angle is exactly the same, looks exactly the same as a 215-degree angle, which is right there. But we had to go 1, 2, 3 times around the circle before we got there. So we go 1, 2, 1, 2, there's 3 times all the way around the circle, and then we get to where we wanted to go. There is my 1295 degree angle. In radians, it looks much the same. If I have an angle that's given as say 12 pi over 5, once again, remember when you're dealing with radian measure, the fact that pi moves into the numerator makes it hard to read. It's the convention, it's something you have to get used to, but when you see 12 pi over 5, I want you to immediately think 12 fifths pi. and 12/5 pi is bigger than 2 pi. So I'm going to subtract off 2 pi, but since it's a fraction, I'll subtract it off in the form of 10/5 pi to get 2/5 pi, or 2 pi over 5. 2 pi over 5 is not a radian measure that I am particularly familiar with, but it is smaller than pi over 2, so I know it's somewhere in the first quadrant. And 12 pi over 5 means I wanted to make a complete loop and then get there. So we can spin around as much as we'd like. Eventually we'll get to where we're looking to go, and that's the idea of a coterminal angle.